Hi guys, I wanted to go over Project 3 today with you. Um, so Project 3, just as a big overarching um, picture, Project 3 is really about the periodic table and bonding, and essentially how we can use a periodic table to determine how we make covalent and ionic bonds. Um, so we're going to talk about the periodic table today, valence electrons, covalent bonding, and ionic bonding. Okay, so our project is broken down into different parts, right? So part one, you're basically doing a little bit of your own periodic table creation with food items. That's part one. Part two has to do with valence electrons and if an element is going to lose or gain electrons. So that's what I'm going to talk about first. And then part three and part four has to do with how we use the periodic table and valence electrons to make ionic and covalent bonds. All right? So let's discuss the periodic table. The periodic table is basically set up in a pattern. So, not a pattern, but trends. So we have metals, which are these light blue colors, metalloids, which are these green ones, and nonmetals, which are yellow in this picture. So we're going to use a periodic table and this idea of metal and nonmetals to determine if um, elements will make ionic or covalent bonds. And we're also going to use a periodic table to help us understand how many valence electrons an element will have. So first and foremost, valence electrons. These are the electrons in the outermost shell. So atoms bond because they want to be have the ideal amount of electrons in their outermost shell. So in the case of hydrogen right here, it has one valence, it has one shell. That's its first shell. Its first shell has one electron in it, and it really only wants one more electron to be full because in the first shell, they only need 2 electrons. Anything greater than the first shell, second and up, they want 8 electrons. And I'm just going to put the letter E for electrons. So looking over here at oxygen, we have 2 valence, or 2 shells. The valence is the outermost. These are valence electrons. So the first shell is full. It has 2 electrons. And the outer one has 1, 2, 3, 4, 5, 6. So it wants 2 because over here I said from the second shell on up, they want 8 electrons. So looking at nitrogen, our outermost shell has 1, 2, 3, 4, 5. So it wants 3 more to get to 8. And carbon has 1, 2, 3, 4. So carbon wants 4 electrons to be full. So how does this relate to the periodic table? Well, we have our columns over here. So this is 1, 2. We're going to disregard basically all of these because these are variable. 3, 4, 5, 6, 7, and 8. With the exception of helium, helium has 2, but every other element in this column has 8. So for the column numbers, for example, 1 over here, every element in this column is going to have 1 valence electron. So lithium's going to have 1, magnesium's going to have 1, or not magnesium, sorry, sodium. Column 2, these all have 2 valence electrons. Column 3 over here, every element has 3, okay? So we're going to use this in a second to determine if an element will gain, lose, or be unreactive with its valence electrons. So in column 1, if these all have 1 valence electron, So lithium's going to want 7, sodium's going to want 7 because we're trying to get to 8, right? With the exception of hydrogen. Hydrogen is at its first, it only has one shell, so hydrogen only wants 1. But every other one is going to want 7. And over here, carbon has 4. It's going to want 4 more electrons. Okay? So now let's discuss how do we determine if it's going to gain, lose, or be unreactive when we're talking about bonding. Okay? So in our first column here, actually let's do our second column. We have beryllium, magnesium, calcium, okay, all these guys. They have 2, they want 6 more. Then these guys over here, including aluminum, they have 3, but they want 5 more, right? Carbon has 4, so it wants 4, etc. So I'm going to give you guys some rules to determine when these elements react, or bond rather, with other elements. How do we know if they're going to either lose the electrons to the other ones that they're bonding to, or if they're going to gain electrons, meaning they're going to take them, or if they're going to be unreactive at all? So here are our rules. If an element has less than 4 valence electrons, I'm just going to abbreviate this, valence electrons, then they're going to just give up, or they're going to lose their electrons to another element that they bond with. Okay? If they have exactly 4, they have exactly 4 valence electrons, they can either lose or gain. So we're going to say they can do either. If they have more than 4, then they're going to gain electrons, meaning they're going to take electrons from another element. And if they have 8, which is this column over here, 8 with the exception of helium, it has 2. If it has 8, or if it's helium and it has 2, it's unreactive. And I'm going to ask you guys, why do you think it's unreactive? If I told you that earlier, atoms basically bond together to get full valence electrons, if they're in this last column over here, these are all full. So they're highly unreactive, which means they're happy, and it's not very likely that they're going to really easily bond with another atom of the same type. Okay? So these are rules in determining they're going to lose, gain, go either way, or be unreactive. Okay, so now I want to talk about what does it look like when these elements bond. So covalent bonding. And let me quickly go over the difference between covalent and ionic bonding. Covalent bonding is between non-metal elements. Okay? So any 2 non-metal elements that bond together, those are going to be covalent bonds. Okay? So calcium and carbon right here, and hydrogen can make bonds together, okay, and those are going to be a covalent bond. An ionic bond is between a metal and a non-metal, okay, so sodium and chlorine would be an ionic bond because it's between non-metal and metal, whereas covalent is between 2 non-metal elements. Okay, so I want to talk about what does covalent bonding look like. So in covalent bonding, we're basically sharing electrons. We're not giving or taking, but we're going to share them. So to determine how we're going to create these bonds, we need to use the periodic table because we have to know how many valence electrons there are and how many each element has. We've discussed right over here. So carbon and hydrogen. So hydrogen has 1 and carbon has 4. So hydrogen only wants 1 more valence electron, where carbon wants 4 more valence electrons. So here's our bond right here. 1 carbon and 4 hydrogens. And I know there are 4 hydrogens because of this number 4 right here at the bottom. If there's no number, then that means we're just assuming that there's 1. So since carbon doesn't have any number attached to it, there's 1. And hydrogen has that little 4, so there's 4. So we already said that carbon has 4 and hydrogen has 1. So hydrogen wants 4 and hydrogen wants 1 and carbon wants 4. So let me draw out, and this should actually say shared. How many are shared? So we're going to put carbon in the middle here, and then we're going to put our hydrogens around it. Okay, and I'm going to draw the electrons around each element and let them be represented by a dot. So hydrogen has 1, so I'm going to put 1 dot around each hydrogen. Okay, carbon has 4. So I start here, 1 dot, 2 dots, 3 dots, 4 dots. So those dots represent the electrons. Now to determine if each element got the number of valence electrons it needed to fill its shell, remember I said hydrogen only needs 2 to be full, but carbon needs 8. I'm going to go ahead and I'm going to count how many electrons are around each element. So here's hydrogen, and because they're sharing, we're going to count the carbon one as well. So hydrogen has 2. There. This hydrogen also has 2 because we're sharing. This carbon has 2, or not carbon, hydrogen has 2, and this other hydrogen has 2. So now every single hydrogen atom is happy. So yes, that's full. Now carbon, because it's sharing, we have 2, 2, 2, and 2. So that's 2, 4, 6, 8. There are 8 electrons around that carbon. So now its valence electron shell is full. So we say total shared between hydrogen and carbon. There's 8 total shared, but I want to know how many are shared by each one. So carbon shares 4. And then each hydrogen shares 1. Okay, so there's a part of your project where you're going to have to tell me, you're going to be given some compounds, and you're going to have to say how many electrons are gained, shared, or lost in that compound. So this is what I want to see. I want to see a specific breakdown of how many electrons are shared or taken or lost, and taken or lost would be in an ionic bonding. So in covalent, you just need to say how many did each element share, or each atom. So let's do another example. Carbon and chlorine. So we just said that before that carbon has 4. And now you may be like, Ms. Mays, I don't remember. How many does chlorine have? We're going to go back to our handy little table. And we see that chlorine is over here in row 7. So that means it has 7 valence electrons. Right? It's right there. Okay, so let's go back to our... So chlorine has 7. And again, I have 1 carbon and 4 chlorines. So here's my carbon. Then I'll put my chlorines around. Actually, let me put that one down just a little bit. All right. So I'm going to go ahead and draw in my electrons around my carbon. So I have 4 represented by a dot. And I'm going to change the color of my chlorine electrons. So chlorine has 7, so go ahead and just start drawing dots around, and we put them evenly. So we're going to go all the way around. That's 4. And then we're going to go backwards. 5, 6. 1, 2, 3, 4, 5, 6, 7. Let's do the other chlorine. 1, 2, 3, 4, 5, 6, 7. And then right here, 1, 2, 3, 4, 5, 6, 7. And our last chlorine. 1, 2, 3, 4, 5, 6, 7. So you should be able to see that each chlorine now has 2, 4, 6, and then this one between the carbon is 8. So each one of those chlorines now has 8, so it's full. And our carbon has 2, here's our 4, here's our 6, and here's our 8. So our carbon's full. So it happened each carbon shared 4, and we only have one carbon, so carbon shared 4. And chlorine, each chlorine shared 1. Okay. Okay, now I want to talk about something which is called a double bond. So this is also in your project. Your project asks you on part 4, which compounds have double or triple bonds? And they're speaking about the compounds that were provided to you in part 3. So you're going to need to basically draw out all of the bonds between your compounds to determine which ones have double or triple bonds. So I'm going to show you how to find out, or I'm going to show you what a double bond looks like. So we have our carbon, and our carbon has 4, right? And our oxygen has 6. I know that off the top of my head, but if you didn't, you would just go back to the periodic table, just like we did in the previous 2, to determine how many. So oxygen needs 2 more to fill to get to 8. And carbon needs 4 more to get to its 8. So I'm going to put my carbon in the middle, and I have 2 oxygens. So I'm going to do 1 on one side and 1 on the other. I'm going to do just what I did in my previous ones. Fill in my valence electrons first for carbon. There's 4. Now oxygen has 6. So 1, 2, 3, 4, 5, 6. And then do it on the other side. 1, 2, 3, 4. 5, 6. Okay, so now I just want to count and see if they're happy just like we did before. So each oxygen has, that's 2, 2, these 2 with the carbon, and then it just has 1 on the bottom. So that's 2, 4, 6, 7. So 7 is not 8, right? It wants 8. And the other oxygen on this side is exactly the same. Now let's just check the carbon. So we have this 2 in the middle here, these 2 here, so that's 2, 4, 5, 6. So our carbon only has 6 and it wants 8, right? So they're both not full in their valence shells. So you may say, oh no, what do I do? All right. So what you're going to do basically is, one second here. Just want to get rid of these guys. So what we're going to do is we're going to move some electrons around. This is how we get to our double bond. So I'm going to take this lone electron that's on the bottom here of the oxygen, and I'm going to move it right here. And I'm going to take this lone electron right here. I'm going to move it over here. And then I'm going to take this lone carbon, move it over here. Then I'm going to move another carbon over here, electron. So basically now what we have is, let me draw it out for you so it's a little bit easier to see. I have my carbon in the middle again. I have oxygen and oxygen. Since I moved 2 carbon electrons over, one from the top and one from the bottom, then I had the original ones hanging out right there. Then I had original oxygen, and then I moved one over, right? I had the original electron over there, and then I moved another one over. Then I saw the 2 on the sides. So now we're basically sharing 2 pairs of electrons. So this is called a double bond. So there's 2, 4, 6, 8. So carbon's happy. And since there's 2, 4, 6, 8, now oxygen's happy. So this is called a double bond. Double. So a triple bond would just be, I'm just going to put a symbol here. A triple bond would be 1, 2, 3. 1, 2, 3. Something like that. Okay? So that would mean there's 1, 2, 3 pairs of electrons being shared. Alright? That's not what this is, but you're asked a question about that on your project. Okay? Alright, now I want to talk about ionic bonding. So covalent bonding was sharing of electrons. Ionic bonding is basically taking, so gaining or losing of electrons. And it's between our metal and non-metal elements. So what I want to show you first here is a bond between sodium and chlorine. So sodium was in row 1, so it has 1 valence electron and it wants 7. And chlorine is in row 7, so it has 7 and it wants 1. Now here's where our rules came in, right? If I said if it has less than 1, then they're going to give up their electrons. And if it has greater than 4, they're going to take electrons. So this means that chlorine is greater than 4, so they're going to be taking sodium's electrons because sodium wants to just give its electrons up. So here's our element. Sodium, it has 1. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. So this sodium electron is going to go over here, basically, and then what we get is sodium that lost an electron. So if you lose an electron, you have a positive charge. And then we have a chlorine who gained an electron, and it has a negative charge, but it has all of its valence electrons filled up. So how many total lost and gained by each? So sodium lost 1, and chlorine, well, let's just say sodium gave 1. And that means chlorine gained 1. Okay? Not too bad. All right, let's look at calcium chloride. All right, and we have 2 chlorines here. So how many valence electrons does chlorine have versus calcium? So let's just go back to our periodic table. Calcium is all the way over here in row 2, so it has 2. And chlorine has 7. Alrighty. Calcium 2, chlorine 7. So calcium, because it has less than 4, is going to give, and then chlorine is going to go ahead and take those. So you'll notice, conveniently, we have 2 chlorines. Let's put our calcium in the middle here. We have 2 chlorines. They each want 1, and calcium has 2 to give. So here's calcium's. They're going to go right over here to chlorine. So chlorine has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So each chlorine goes over to the other side. And then you're left with, each calcium goes over to the chlorine. So we have calcium. It lost 2. So it has a positive 2 charge, and each chlorine now has a full octet, and they have a negative charge each because they took 1 electron. So each calcium, or there's only 1 calcium, calcium lost 2 electrons, and each chlorine gained 1 electron. Okay, so this is basically how you determine which one's lost, which one's gained, and how bonds are created. So you can use this information to help you on the project. You'll be asking or answering questions about valence electrons, covalent bonds, ionic bonds, how you determine which compounds are covalent or ionic, and then how many electrons are gained or lost in each one of the compounds. So your periodic table is basically your best friend over here, right? It's got if it's metal or non-metal, which will let you know if it's ionic or covalent. It also has the number of valence electrons. Ignore basically all of the stuff right here. But 1, 2, 3, 4, 5, 6, 7, 8. That lets you know how many valence electrons you have. All right, if you guys have any questions or concerns with your project, let me know and I'll be happy to help.